Okay, so we did a project based on electromagnetism, and it's by Bajer Sawas, me, Sal Ortiz, and Coleman Rogers. Okay, next. So who discovered electromagnetism? So William Sturgeon was the English physicist and inventor who made the first electromagnetics and invented the first protocol English electric motor. The first electromagnetic he built was a horseshoe-shaped piece of iron that was wrapped with a loosely wounded coil of several turns. He displayed its power by lifting 9 pounds with a 7-ounce piece of iron wrapped with wires through which the current of a single-cell battery was sent. A fun fact, he made the electromagnetic a shape of a horseshoe because it was to increase the magnetic flux at the lifting end. It was high peak fields because there are two opposite poles there. Construct that with a typical wire magnet which only has half of the peak lifting power, since there is only one pole where lifting is done. Okay, next. So what is electromagnetism? It's a magnetic field created by the flow of electron throughout conductor, such as a wire or a cable. A north and south pole is created depending on the direction of electron flow. While there's a permanent magnet material, electromagnets are a result of a direct relationship between electricity and magnetism. Okay, next. So a quick history of this project was our project consisted of generating a magnet with different powers outputs. For this project, we used a variety of magnetic wire to see how the outcome will be. If it was going to have an impact due to the different wire cable used. And another impact factor when it comes to how strong the magnet is the different output voltage battery and the different nail components. Next. So the problem statement we had for this project was like the factors determine electromagnetic strength. And so for this test, we evaluated how the number of wraps along the varying voltages affect the magnetic strength of our electromagnetics. Mag- Okay, next. So the supplies we had to use for this project was screws, a 1.5, 6, and a 9 voltage batteries, a digital scale, a large iron nut, a copper wire from 18 wires to 16 strand wire, a multimeter, and a computer to calculate the outputs. So the data collection, the data we collected for this project was to determine number of wraps on the screw being tested, how many wraps that has to be made, the measured voltage of battery, the serial out scale, connected battery, and determine the negative readout of a scale. Okay, next. Some assumptions we had in considerations for this project was copper wrap spacing not perfectly consistent. The total copper wrap length was not set consistent. Measuring equipment precision, connecting of electrical components, and spacing of magnets to scale the weight not consistent across all screws.
Hello everyone. Our presentation about electromagnetic, and here my small station. I'm going to walk you through to how I did my work, what tools I use, and what the result I get. Here we go. It look funny, but this is where I want to put my phone so when I do the testing, so it's not part of the test. Anyway, my initial plan was to carry this bar. It's not heavy, only 40 pounds, but unfortunately did not work. So we go with the small screws, also did not work. So finally I get very small screw. I get some result. Here the test. I'm going to start doing the test. I use wire, cat 6 wire, twist wire. I use my touch to remove the insulation, the plastic insulation, and here what I get, here the nail and the connection, it's a 30 double wire, call it 60. And here now I'm going to put like the 2 battery to see what we're going to get. Stay with me. Here's the battery. And here's the second battery. And now we're going to put this one. And now after I connect the 2 battery, I'm going to put it. As you see, the result, it look really good. It take like almost 2.6. Unfortunately, I need to replace the battery a few times. So in order to get the result, the test, it's not really precise. Every time I get different result. Sometimes even the battery, I put the battery, did not work, sometimes work. And here what we get. Thank you for watching. If you like it, give me thumb up. See you in next video. Bye bye.
Maher, did you have any comments on that?
Yes, I just want to add like a few things. Uh, One of them is using a lithium battery. It helps a lot to keep the result stable, because the voltage in a regular battery drop a big time as soon as we turn on the power. And um, and the other things, it's always keep like whenever we do the test, and I did not get exactly the right amount of screws when I do it the next route. And that's it.
Here is our setup for measuring the magnetic strength of 3 different test scenarios here. So we're going to be testing the 50 wrap, which is basically a nail that is wrapped 50 times with I don't know exactly what gauge wire it is, but it's 18 gauge wire, 16 strands, so it would be 1/16 of 18 gauge wire. I basically just uncoiled this whole thing and took it out of an 18 gauge wire jacket. So we've got the 50, we've got the 100, it's not focusing very well there, and then we have the 150 right here. Okay, so we're going to test them individually, and for this video I'm just going to show you kind of how the test setup works. So we're going to take our battery. These are 1.5 volt AA batteries, and what we're going to do is, let me show you exactly how I'm collecting data. What we're going to do is first measure the voltage. Okay, so we measure the voltage by turning our multimeter to the voltage position and direct current, signified by the straight line and dashed line. Alright, so now we're going to measure the battery voltage, just like we did in class that one day. Okay, and so we know that this is not getting a good reading. One second. Okay, so that's 1.52 volts. So I have a chart, and I've been writing it down. So 1.52 volts. This is for our 50 wrap. Okay. And so what we're going to do here is, here are the 2 contacts for the 50 wrap magnet. So there's one right here in my left hand and one right here in my right hand. So all I'm doing is, and this is, you know, part of the reason why we're getting some inconsistent data is due to the fact of how I'm connecting these. They don't have solid connections at all. Come over here to the... Okay, and so you can see the space between that nut and the end of that nail. It's also hard to keep that consistent all the way across because I don't have the instrumentation required to get that sort of measurement. But so our scale is zeroed out with the nut on it, and we're going to take our two ends, connect them together. Okay, and what does our scale read? Negative 2.6 grams. Okay, unconnect it, disconnect it, and we're back to zero. So that means that that screw just lifted that nut 2.6 grams.
Okay, so as you can see, my header and column Smith project over this magnetics. So now is the data we collected for this project. So from this data, we determined by the averages that 150 reps has the greatest magnetic force, as also the 100 reps possibly encounter inconsistent testing methods or design faults leading to mixed results in which average was lower than the 50 reps average, as you can see in the table. And so for the graphs, here are the graphs for the 50, 100, and 150 reps. So the results show that there is a clear difference in magnetic force between 150 reps than the ones from 100 and just 50 reps. The results also show the little difference between 150 reps. You know, so the resulting line graph shows that is most likely inconsistent in assembly and data gathering methods. Okay, next. In conclusion for our project, we have evidence that the greater the number of wraps around an iron core is the greater magnetic force. From this data, we can also conclude that there is in fact a decrease in magnetic strength related to the lowering of battery voltages during testing. Our data has many faults due to inconsistent assembly methods. While we have collected data, the instrumentation and collection methods are not designed to the precision required to collect reliable data that could be used to make a trend. Thank you very much, guys.
Thank you.
See you.